Welcome to Study Loop.
This problem uses Newton's law of cooling, and we see when we read through the lesson in the book that Newton's law of cooling fits the model for exponential growth and decay, y equals y naught e to the kt. And we can also make it a little bit more problem specific if we replace the y with t minus t sub s. T is the final temperature of the object, T sub s is the temperature of the surroundings, and we can replace y naught with T naught minus T sub s. T naught is the initial temperature of the object, and T sub s is the temperature of the surroundings. So for this problem, we know the temperature of the surroundings, that would be the room temperature, is 75 degrees Fahrenheit. And we also know the initial temperature of the object, which is turkey, because it comes out of the oven at 185 degrees. So we can go ahead and substitute those numbers into our equation, and we have T minus 75 equals 185 minus 75 times e raised to the power kt. We haven't found k yet. Okay, so what we want to do is use this point that we're given. The temperature of the turkey is 150 degrees when the time is 30, and we're going to use that to help us find the value of k. So we'll substitute 150 in for the temperature, the final temperature. We can go ahead and subtract the 75 from the 185, and that gives us 110. And we can put 30 minutes in for the time, and we'll solve this for k. 150 minus 75 is 75. Then we're going to divide both sides by 110. Oops, that's supposed to say 110. And we end up with 75 divided by 110 simplifies to be 15 over 22. So 15 over 22 equals e to the 30k. We take the natural log of both sides, and then we divide both sides by 30. So we have k equals natural log of 15 over 22 divided by 30. So this gives us our model, which for this problem is going to be t minus 75 equals 110 times e to the natural log of 15 over 22 times 30 over 30 times t. Okay, so we're going to use that model to help us finish part A, which is to find the temperature when the time is 45 minutes. So here's that model again, and we're going to substitute 45 in for the time. And this all goes in the calculator very, very carefully, making sure to have all the parentheses in the right place. And we end up with T minus 75 equals approximately 62 degrees. So now we're going to add 75 to that, and we get approximately 137 degrees. So that tells us that at 45 minutes, the turkey would be 137 degrees. Okay, let's move on to part B. So in this part, we're figuring out the time when the temperature is 100 degrees. So we can take the same model, which we have right here, and we can substitute 100 in for capital T, and we're going to solve for lowercase t. Okay, so let's subtract, and we get 25, and then we're going to go ahead and divide both sides by 110. And 25 divided by 110 simplifies to be 5 over 22. And then we're going to take the natural log of both sides. And now to get t by itself, let's multiply both sides by the reciprocal of this fraction. So we end up with t equals 30 times the natural log of 5 over 22 divided by the natural log of 15 over 22. So we also carefully put that into a calculator, and we end up with approximately 116 minutes.